Imagine this. Tomorrow the sun turns green. The sky goes emerald, right? The disk glows lime? Here's the twist. Most people would barely notice. It sounds like a trick, but it's just how light and vision work. The sun doesn't emit one color. It throws out a wide mix of wavelengths with a peak roughly in the green part of the spectrum. That peak doesn't make the sun look green because your eyes have three kinds of cones, S, M, and L, sensitive to different ranges. Broad daylight stimulates all three, and your brain blends those signals into something close to white. Even if we nudge the sun's peak deeper into the green, the light would still be a wide blend. Your visual system would keep calling it white. Maybe with a tiny shift you'd only catch with instruments or a careful white balance check. What about the sky? If the sun gets greener, doesn't the atmosphere tint accordingly? Not really. Daytime blue comes from Rayleigh scattering, which strongly favors shorter wavelengths. There would still be plenty of short wavelength light to scatter, so the sky stays blue. Sunsets might pick up subtle differences, slightly altered hues when light slants through more air, but the midday look of the world wouldn't flip to green. Energy and climate? If the total solar power remains the same, Earth's energy budget barely budges. Yes, the atmosphere absorbs and reflects different wavelengths a bit differently, but those shifts are small next to the big players: seasons, clouds, ice, ocean heat. No apocalypse, no instant ice age, no global heat spike just because the spectral peak slid a notch. Plants? A common myth says more green light means supercharged growth. Not so fast. Chlorophylls are most efficient in blue and red. That's part of why leaves look green. Much of the green gets reflected. Still, plants don't give up easily. They use accessory pigments and clever energy transfer tricks. With broad daylight still intact, photosynthesis would continue. Ecosystems might adjust at the margins, but there's no mass die-off from a modest spectral shuffle. Solar panels? Photovoltaics are tuned to certain wavelengths but work across a band. A spectrum nudge toward green might shave or boost a few percentage points depending on the tech, but engineers already juggle coatings, materials, and cell stacks to handle real-world sunlight. Your rooftop array won't turn to junk overnight. So where would you notice anything? In small ways. Photographers would see it first: a slightly different white balance, a subtle shift in how metals, water, or foliage reflect midday light. Instruments would spot the change immediately. Casual eyes? Most days would feel normal. If you want a kitchen table demo, try this. Shine red, green, and blue flashlights onto the same white wall. Together they look nearly white. Dim the red a bit. The patch doesn't suddenly go green, it just gets cooler. That's the sun story. Change the mix, not to a single color, and your brain still reports daylight. While we're here, let's clear up the green flash. Sometimes, right at sunset, a tiny emerald wink appears. That's an atmospheric refraction trick at the horizon, not the sun turning green. It lasts a second and depends on layers of air bending light differently, like a natural prism. Cool, but unrelated. Now, a wild thought experiment. What if the sun became a narrow-band, laser-like green source? Then things would get weird. The sky could darken because there's far less shortwave light to scatter. Shadows would sharpen, surfaces would heat unevenly. Photosynthesis would suffer because plants crave a broader buffet. But stars aren't lasers. Real stellar light is thermal and spread out. The laser sun is sci-fi, useful only to show why narrow light would genuinely change our world, precisely because it's not how suns work. And that's the punchline. We can repaint the sun in our imagination, but physics repaints it back to white. Broad spectra, three-cone vision, and atmospheric scattering conspire to make daylight look familiar despite a green label. The sky stays blue. The sun's face stays near white. Plants keep running on the parts of the spectrum they like best. Panels keep humming. Life goes on, mostly unbothered. So the next time someone asks, if the sun turned green, would everything look green? You've got the answer. Colors aren't just about a single wavelength. They're about mixtures and how our eyes decode them. Change the recipe a little and the meal still tastes like daylight. If you enjoyed counterintuitive what-ifs that unravel into simple truths, drop your next idea. Purple skies forever? Two suns at noon? We'll take the strangest one and test it against reality. No jargon, just clear steps from myth to fact.